Alright, so let's take a look at this problem number 6. Again, it's the same directions, asking us to determine whether this is an even function or an odd function or neither. So if I have a graph, then I look for symmetries. If I have an equation, I use the algebraic definition. I'm interested each time in just coming in and saying, what is this function evaluated at the opposite of x? Well, first of all, let's take a look and see what the rule is. What does this function do to any input that you give it? And it looks to me here that it always creates an addition problem. And the first term is 1 divided by the input. No matter what you give it, it's going to take the reciprocal of what you give it. And then it's going to add the number 2. So the only thing that we can't give this, that we can't take the reciprocal of, is the number 0, or any expression that is equal to 0. So if I give it the opposite of x, it's going to take the reciprocal of the opposite of x, and it's going to add it to 2. Okay. Well, I can see that these first terms are equal and opposite, so I can easily see that f evaluated at negative x is not the same as the original function. That these are two different outputs. When the input is equal and opposite, the output will not be the same. There may be one specific number, maybe that it is, but in general, it's not always going to be true. Therefore, I know this is not an even function. Alright, so now let's take a little bit closer look at this, the f evaluated at the opposite of x. What if I took the opposite of this function? If by taking the opposite of this function, I get the original function, I'm going to declare it an odd function. So if I take the opposite of this function I've just found the expression for, I have to take the opposite of every term. So I'm multiplying both sides of this equation by -1. When I take the opposite of this first term, I get 1 over x. When I take the opposite of the second term, I get -2. And I compare it against the original. Well, remember we said that f evaluated at the opposite of x was not the original. And now if you look at the opposite of f evaluated at negative x, it's not the original. So this is not an odd function. So it's not even, it's not odd. We say that it's neither. It's neither even nor odd. Alright, so I hope that helps. Oh, wait a minute. We saw a little bit of our shortcuts and stuff looking at the exponent and determining whether it's even or odd function. If I had just 1 over x, then this x is raised to the first power, and I would say, hey, that's an odd function by my shortcut. But I haven't added anything to it. When that's 0, we are still going to have symmetry with respect to the origin. Remember, this 1 over x is one of our library of basic functions. When you see 1 over x, you should be able to easily visualize a graph that looks something like this. Okay, and if I'm adding 0, then I'm not lifting this graph up or down, and if I spin this graph about the origin, I get the same graph. Okay, now what if I were to have lifted that up by 2 units? What would I have? Well, let's do it in a different color here. Then this x-axis, where this graph doesn't touch it, this portion of the graph would be lifted up to there, and this portion of the graph would be lifted up to there. Okay, so when I rotate this 180 degrees, this line is 2 units above the x-axis. When I rotate this 180 degrees, that line is now 2 units below. There's no way that this green graph is the same as the graph that I started with, because this dashed line, this horizontal dashed line, we're going to learn that they call that a horizontal asymptote. These graphs are getting closer as you move away from the origin. The output of this function is getting closer and closer. I said x equals 2 and I meant to put y equals 2 right there. Getting closer and closer to this line. Well, that line is positive 2 there, and if you rotate it, that line is now y equals negative 2 in that picture, and the y values are getting closer and closer to negative 2. It's clearly not the same graph. So it is not an odd function, and like we said, it doesn't have some, if it'd have, this side would be a mirror image of the other side if it were an even function. So since it's not even and it's not odd, we say it's neither.